Hi, today I'm going to explain working of my project cyberbullying detection in Telugu. We are using BERT model. Motive of this project is to detect the toxic words which are commented in Telugu and English using BERT models. The reason for starting the project is there is a large amount of toxic comments, tweets which are present in the local languages like Telugu. Most of the detection systems only focus on English and can't detect other languages, and they won't remove those comments or tweets. Being from Andhra Pradesh, I observed many Telugu comments on Instagram and Twitter which remain undetected. Telugu often appears in forms of pure Telugu script, or either they comment in English or both combined with the pure Telugu and English. These factors made the detection difficult. Cyberbullying detection faces some major challenges, especially in Telugu, because there is a lack of high quality data sets which are in Telugu language, informal social media language rather than formal language which follows grammatical rules. Script mixing, as mentioned earlier, some comments use both Telugu and English combined to express their idea, and creative spellings and slangs. Creative spellings like KCPD and all, and slang, it depends on the trending memes and all. Existing tools are trained mostly on English, hence we decided to go with cyberbullying detection for Telugu. Our main objectives are build a cyberbullying dataset which is based on Telugu, pre-process it and clean it. And using the pre-processed dataset, we wanted to train few word models, compare which model performs better, and try to develop a real-time prediction system. We have integrated a YouTube comment section detection in our project. Major challenge, there is no data set which is available in Telugu, so we spent a lot of time, like it took us around a month to create the data set, in which we collected the data using web scraping from YouTube, Twitter and Instagram. The raw data set has around 4,000 comments. We labeled each and every one of them manually. After cleaning, we got around 37,000 samples which we balanced further. The language consists of mainly Telugu and English. Each comment was labeled as toxic and non-toxic. The current project is only binary classification, not multi-class, because the dataset is having only 37,000 words. We are unable to get a good accuracy on multi-class classification. This is what the dataset looks like. Further, we have pre-processed the data. We used a Unicode normalization. We removed URLs, emails, any numbers or emojis, and certain invisible characters which they paste from other sources. And we tried to convert the data into lowercase, and we removed any duplicate comments also. Pre-processing plays a major role in obtaining required accuracy. The raw data set has about 67% of non-toxic comments and 33% of toxic comments. But if we proceeded with the dataset, the model might predict non-toxic for toxic words also. Hence, we balanced the data. We undersampled the non-toxic comments, and we made the final balanced dataset. Dataset was further split into test, train, and validation data. Training, it has about 80% of our dataset, and validation and testing, we gave 10%. We prevented any duplications across the splits because data leakage could increase the model accuracy. Data augmentation. In the previous raw data set, we have applied basic augmentation to increase a bit. To increase some more examples, we used removing repeated characters and text normalization. Model architecture, we proceeded to go with BERT models rather than normal ML models like LSTM, but has a few advantages, like BERT understands the context and the attention makes BERT a better model. BERT also captures the relationship between the words. BERT also have multi-head attention. As I mentioned earlier, attention helps in understanding whether the word fits the sentence or not. And it also uses FFN. It also uses layer normalization. Hence, we proceeded to go with BERT. We chose around 7 different models. We proceeded to go with IndicBERT, XML-RoBERTa BERT, and multilingual BERT, and DistilBERT, and two mini and tiny BERT models. We wanted to compare and identify which performs well. We have selected IndicBERT because it is trained on Indian language and we expected it to perform better in Telugu. We proceeded with mBERT because it's trained on several languages and it could identify new regional language better than a normal model. XLM-RoBERTa is a large multilingual transformer trained on web data. DistilBERT is a small version of BERT, but it has faster inference. BERT Mini and Tiny we have used mainly while testing the project. It's lightweight, hence we proceeded with training configuration. We are using a personal laptop with a limited GPU memory, so hyperparameters for chosen such that it balances the model performance and the resources we have. Based upon the model size, we have used these parameters. Also, we used AdamW as an optimizer. Evaluation metrics, we proceeded to use accuracy, precision, recall F1 score, MCC, and AEON methodology. First, we have collected the data and pre-processed it, and we saved it as a CSV file with pre-processing steps I have mentioned earlier. The data balancing, as I mentioned, the non-toxic data is more. Hence, we undersampled the non-toxic data and saved it as a CSV. Data is further split into testing, training, and validation. Model training, we have used 7 models. Implementation, while implementing, we used AdamW and mixed precision for GPU optimization. We have saved the trained models, weights, and tokenizers locally. Model is evaluated, which further provides us confusion matrix and also a classification report. Real-time prediction, we also made a prediction page where we can give a single text or a batch CSV file. And further, we also created a page where we will give YouTube comment link, and using a YouTube API, it fetches the live comments and it classifies whether it's a cyberbullying or not. You can also download the output in a CSV format. Implementation, the app.py have a central Streamlit router and a navigation to dashboard and all the other pages. Data summary page is used to give information about the given CSV file. It also has a word cloud and frequency filter. Data balancing is used to oversample or undersample the given data. Model training, we have downloaded the models offline. As mentioned earlier, we have used AdamW and few other methods like AMP to optimize the GPU usage. Model evaluation, it creates us how well the model is performing, gives us the loss and other information like accuracy, precision. Predict.py predicts the given single text or CSV file and returns the output. We can choose which model to use in the prediction page. And YouTube model, we will give the YouTube link and it extracts a certain number of comments and predicts whether they are cyberbullying or not. These are the model performances. We got top results from mBERT, DistilBERT, and IndicBERT. mBERT is the largest model we have used, and obviously we got better accuracy for it. DistilBERT is a mid-range model which we have used, and it gave us around 79% accuracy. IndicBERT gave around 97%. These accuracies are the highest accuracies we observed when we are testing. Larger models obviously achieved a higher accuracy. DistilBERT offered the best performance efficiency trade-off. These are the training loss graph and confusion matrices for each of the model. We implemented YouTube comment predictor, as I mentioned, where we give YouTube link and using Google API key, we will fetch some comments and comments are cleaned and model predicts the toxicity. Models are classified either as cyberbullying or not cyberbullying or uncertain when it doesn't have information of it while training. These are the possible improvements which we can do in this project. Multi-class toxicity classification. As I mentioned earlier, we weren't able to get great accuracy while testing multi-class toxicity because each class has a less number of examples when compared to binary classification like toxic or non-toxic, and models require a large amount of data. Hence, we couldn't get a better accuracy. And hate speech categories like whether it's based on religion or caste, we can detect based on it. Multimodal detection, like right now we are using only text. Further, we can also improve by detecting text from an image also. And we can make our data set larger by web scraping further. We are also planning to create an extension which scrapes the data present in the web page and gives us the output whether the data is having any cyberbullying sentences or not. This is the UI which we deployed using a Streamlit. This is having certain features, and everything is dynamic. Like we can balance the data and check whether the data set is balanced or not, or data summary. And as I mentioned, we have balanced the data set and such that it's equal, so the model gives us better accuracy. You are having these multi-class toxicity, but as you can see, very less number of examples are present. Hence, we proceeded to go with binary classification. The data set is having English, and Telugu language. This is the word cloud, and from here we can select the data set CSV file, and we can balance by selecting undersampling or oversampling. We can preview the balanced data and save it. We can split the data you want. We proceeded to go with 80-10-10, and we can save it from here. Model training, we will select the train CSV path and validation CSV path. It detects what they are having, and we can select the model. Among these 7, we can select any model. After training the models, weights and the tokenizers get saved locally, so we can use them further while checking performance or predicting. Using the test CSV and selecting any model, we can evaluate the model and check its accuracy, precision, and all. This is the prediction page where we can select any model which we like, and we can give either single text or batch CSV. It has loaded our model using the local folder. We can give any word and it detects whether it's a bad word or not. We got the confidence rate and it's toxic, gave as non-toxic, confidence is high. Further, we can use YouTube count cyberbullying prediction page. We can select the model which we want, and we can use a confidence threshold based on which the model predicts whether it's a toxic or not. And we can paste the link here and number of comments to fetch. After clicking fetch using the API, it fetches some comments, and our model predicts them whether they are cyberbullying or not. We can download this output as CSV. This is my project. Thanks.